Hey guys, in this video I'll talk about the alternating series test, which is one of my favorite series tests because it's very intuitive and easy to understand. Now I know one of the hardest parts of calc is knowing all the series tests and understanding when to use them. So in this video we'll look at this test visually, so we'll really understand how it works instead of having to blindly memorize it. So we can use this test when our terms alternate positive and negative, and the absolute values of our terms decrease. We can represent this with a series where a, b, c, d, and all these variables represent the absolute values, and they all decrease. Now our terms of this series are a, negative b, c, negative d, and so on. So all the signs alternate. Now we'll show this sum on a number line. We start off with some value a, which we can represent here. Now we add negative b, so we subtract b. We can show this by a backward facing arrow, where the length represents the absolute value of b, and it's negative representing subtraction, so it faces backwards. And we end up with a point here. Now we know that all the terms alternate positive and negative. So all of these arrows must alternate forward, backward, and so on. Since this arrow went backwards, the next arrow must go forwards. We also know that the absolute values decrease, meaning the lengths of these arrows must get smaller and smaller. So our next arrow, where we add c, might look something like this and give us a point here. If we keep going, we see something like this. All the arrows get smaller and smaller and continuously reverse direction. Now we see on this line that these values converge, and it makes sense that if we keep going on to infinity, this would converge to one point, since the extreme values keep getting narrower and narrower, and will end up at one point. Now let's take a look at some examples. In order to use the alternating series test to show that some series converges, these two must be satisfied. So let's take a look at the first condition. We know that this must alternate positive and negative, since we see negative 1 to the power of n, meaning all the even elements would be positive and the odd elements would be negative. So this is satisfied. Now we take the absolute value of this, and we see 1 over n. We know that this decreases, so this condition is also satisfied. Since both of these conditions are satisfied, this series converges using the alternating series test. Now what about this example? Once again, we have to prove that these two are applicable. Similar to the first case, we know that this also alternates positive and negative because it has negative 1 to the power of n. So the first condition is satisfied. Now, the second condition says that these absolute values must decrease. The absolute value of this series is just 1. So the absolute value of all the terms are just 1. This series does not satisfy this condition. So this fails the condition, and we cannot use the alternating series test. Notice that we can't say that we prove that it diverges using the alternating series test, because this test only shows that it converges if you have these two situations. But we could go on and prove that this diverges by showing that the limit of this series as n approaches infinity is not 0. As n grows bigger and bigger, this would still alternate between negative 1 and 1 and would not end in 0. So that would be using the divergence test. So using the alternating series test, we're able to easily prove that some series converge if they follow these two situations. If you like this video, please remember to click that like button below and subscribe to my channel. And if you have any questions or would like to see any specific videos, comment them down below and I'll get back to you as soon as possible.